overview of our machines, our capabilities, and how we're going to market. As you may well know, Jameson came into the market last year, partnered with a company called Noramco, made out of Denmark. Most of our competitors are out of the European nations as well, a little more advanced on it than we are over here in North America. Anyway, we'll get into it real quick because I know everybody's got stuff to do today. First off, I'll get rid of this. There we go. Couple things: traditional versus micro technology. We're hearing more and more people move away from the traditional installations of telephony as well as telecommunications, going from inch and a quarter conduit being the kind of gold standard for years, and using loose tube or ribbon fiber. Now we're seeing more and more people move to the micro fiber, micro duct solutions. FuturePath and Duraline, MTEL makes some. Almost every HDP manufacturer is making more of the smaller ducts for the smaller fibers that these manufacturers are making new ones pretty much daily. The good news is we have machines for both. For those of you not familiar, I got through the slide here, which I showed my team. The kind of traditional ways of doing a encasement pipe with smaller conduits inside of it and using smaller ducts. And if you look at the bottom, the way most guys are doing it now with FuturePath and very small microducts with inside of larger encasement ducts. A lot more fiber density, a lot more pathways that they could either lease out to other guys as dark fiber networks or use for future expansion. And you guys, if I'm going too fast, unmute yourself and tell me, hey, slow down. This is kind of an overview sheet. This to Amanda's in a much more clean version. This is kind of stretched out here, but it kind of shows you we have basically 5 different machines we're going to market with, and we'll start with the Nano Flow on the left-hand side here. This machine is really an enterprise machine for smaller fibers up to a 3.5, 3.6 millimeter fiber, up to duct sizes, microduct sizes, up to a 10 millimeter OD. Works well with really any kind of fiber. We've got some stuff going with AFL as well as Corning and Clearfield on this one. But really enterprise, in building, potentially if somebody's running around fiber as a fiber to home drop cable. Battery powered, comes in its own case, gives you basically allotment of all the duct sizes up to 10 millimeter, as well as getting 2 adapter plates, which would cover a large range of fiber sizes. So really it's all in one buy, a great little unit with not a lot of things needed to add on to it. Next up is our microflow unit, which is a electrical unit, plug into the wall, 110 outlet unit. It goes a little bit larger on the fiber size, as well as a little bit larger on the duct size. This is the highest selling machine they have in Europe. Noramco does. This machine, you can set the ramp up speed from the beginning, start very slow, and run a set distance, say 4,000 feet, and then slow down near the end to come to a stop. I'm not sure how much real presence we'll have for this. Again, it's a very small, on the smaller side of the fiber spectrum, inside building, hospitals, municipalities, college campus, what have you. But the next part is we have it. I'm not sure how much demand we'll have for it out there. The good news is we have that capability. We are currently working on making a unit that's kind of a combination of both of these, as well as potentially looking into a drill drive unit like our competitors have, which I'm kind of resistant to. More to come on that later. Now we'll get in the meat of where I really think we have a lot of play in the market. The Mini Flow Rapid right there in the middle. This machine is made for those FuturePath microduct installs. This one goes up to 20 millimeter microduct, and then all the way down to a very, very small 0.28. I'm sorry, I can't read. Basically down to a 3 millimeter microduct OD. That's really how we work off OD. So this machine is a hydraulic driven machine with a hydraulic power pack. We use air to float the cable. The air is not pushing it. It is not a pneumatic machine at all that would run off a captured air device at the end to pull the cable down. We believe that the air is there to wrap around with a Venturi effect to keep the cable floated, take the friction off, and use the hydraulic power to push the cable into the conduit. We have tested this with Canada, and I believe they love the machine. And we're working to get approval. We did work with flat drop in our test yard. It will work with flat drop. I'm working at some videos to send up there to you guys at Bell Canada to hopefully get the final approval from them on this machine. Another benefit of this machine, as well as the next two I'll talk about with the hydraulics, our machine will go in reverse. Doesn't sound like a big thing, but to a lot of guys it can be. If you're running into conduit that's coupled up, where you're trying to get longer distances and you run into a coupler or run into a snag, we can back the machine up and then move forward again and hopefully get it orientated in a position that will actually allow it to pass. Or if you've got a cable that has hit a dead end, a snag, a pinch in the conduit, you can use the machine to extract that fiber back out. Or if, in some cases, if they've got an old medium of coax or something else in that conduit they want to reuse, we can use this machine to pull that existing medium out to then install new fiber. So when most guys see it, they love it. With a captured air device that's a full pneumatic, air-driven only, you can't go in reverse. Otherwise, you're pulling against the air. Again, with this mini flow, you've got a set of little adapter plates that go by the fiber size and the conduit size. We've got a wide range of seals, whatnot, to make the deployment very, very quick compared to our competitors. This machine, if we get out there in front of the customer with it, sell itself, it is a amazing little piece of machinery. The power flow and the multi-flow, next up, we'll kind of pass over the power flow for a minute and move on to the largest machine on the right-hand side, our multi-flow. This competes with the GMP Tornado, the Gulfstream 400, and the Plymouth Superjet. This machine is for your larger cables, your larger conduit designs, going up to 2-inch diameter conduit, all the way down to microducts 14 millimeter and larger, depending on the inlet. This machine also will realign existing conduits. If you have conduits out there that you want to put microducts in, you can use this machine to actually push in microducts inside of an existing 1.25 inch, 1.5 inch, 2 inch, 1.75 inch if you really wanted to. But you can use the machine for both cable installation as well as microduct installation. That's what makes it great. The power flow next to it is for cable only. A little bit smaller than the multi-flow, a little less powerful hydraulics, but the same principle altogether, except for the power flow will not allow you to realign with microducts. So it's about a $1,000 to $2,000 difference in price. Pretty much easy to sell the upsell on the multi-flow as a larger machine, more powerful machine, and as well as the ability to, if you ever want it, to do to realign. When we didn't talk about distances, you'll hear people say, well, how far can it go? How fast can it go? The reality comes down to is it depends on the run of the conduit. It depends on how it was implemented, how it was put in, if it was bored in, if it was plowed in, how many 90s you've got. Really, the machine is set to go a long ways, depending how it's coupled together and the run. Each one is different. Moving on from there, this is kind of a design of how our machine's set up. If you know in CB4, you basically have your fiber reel on the left-hand side. Your hydraulic pump goes to the machine, and so we want to run about 110 bar of air pressure. So within each machine, there kind of has some parameters on that previous sheet that kind of shows you what we'll need. I don't want you guys to worry about that too much. I'll take care of all that when we get into a demo or a situation of what they need. This also shows on there that we run a cooler dryer between the air compressor and the machine. I'm not sure much in Canada you'll need that up there in the southern part of the United States where you're running very hot compressed air into the machine. It heats up even more. The hot air causes a problem. So we developed a cooler dryer that is a pass between the compressor and the machine. I don't know how much you guys will need that up there, but again, no, we have it if you need it. And you hook up to the existing conduit to the ground. Since I did a setup, we get more involved as you guys get more questions. So this kind of shows, this is a slide Noramco put together. It kind of shows how the cable is interacting with the machine. It's the air pressure coming down through the flex blocking chamber that is basically
flowing through the conduit. Again, it's floating the cable. We're not using the air so much to push it. There will be some push factor, but for the most part, the air is swirling around the conduit, lifting it off of lifting the cable off the conduit, reducing the amount of friction. Also, you can see here, there is water as well. We could use a machine instead of using air. You can use water to float it. I've not done one here. I've seen videos of it. It is capable for larger cables, and where you use that, you're going to get a lot more distance out of using water. The problem is in the United States, the EPA, or Environmental Protection Agency, is going to have a large problem with what you do with the water when it comes out the other end. How are you reclaiming it? Is that water dirty now, or need to be filtered, or whatever? Not seeing a huge movement for that right now. Next slide. We talk about distance. We talk about how far it'll go, how fast it'll go. It really comes down to a calculation of how much friction that cable has. When you're pulling with pull tape, pulling a cable, you can only go so far before that cable is just dragging along the conduit. And if you're going through loops that are extended through handholds, you're adding much more friction. So fire blowing, same principle. It really depends on how the conduit was laid in there, how much friction you have versus how much power you have to push it. That's where the hydraulics come in this machine versus an air-driven machine. We have a lot more power by pushing with hydraulics than we do just pushing with air. That's one of the selling features we have over some of the pneumatic machines. Fill ratio. When we look at what a customer wants to do versus what's actually recommended or what's capable, you want to be about a 70 to 75% fill ratio of the conduit. We don't want to try and shove a inch and a quarter cable into an inch and a quarter conduit. There's not enough room around it to get the air around it to fill it. Same principle, we don't want to shove a very, very tiny cable in a very, very large conduit. We're not going to get any swirl effect. It's actually going to potentially damage that cable as it starts whipping and swirling and moving inside that conduit. So when it comes down to what the customer wants, we ask them what size conduit they're using for sure, what size cable they're using, so we can actually kind of guide them on saying we don't recommend it, or we would recommend it. And again, I'm here to help you guys out with that. Again, that was a duct installed, a lower friction, trenched-in conduit versus a directional board like on the bottom where you got lots of 90s and turns and ups and downs. You're going to get a lot further on a low friction run versus a high friction run. Some differences between our hydraulic versus air driven. As I said before, with a hydraulic, we can move it back and forwards, back the cable up, ramp it up through junction blocks, tricky points, whatnot. With an air driven machine, when you run out of, when the friction builds up and you have no more air drive behind it, you're dead in the water. That's not moving. We don't need as high of an air compressor with ours versus the air-driven ones only. The hydraulic is going to take care of a lot of the pushing force. It's a lot of wasted energy with the air-driven. Also, with ours, you can actually use the machine without air as needed. A lot of your runs will start off where you're just using the hydraulics to push it and using the air as needed. One thing we see in the field all the time is people do a installation with our machine. They want to crack the air open all the way right at the onset. In principle, this is going to be catastrophic. The air is going to rush all the way out and then actually pull back in towards the machine and prevent the cable from going through. Instead, I recommend running the machine with the hydraulics only, getting in there, depending on the size of the cable and conduit, several hundred feet potentially, and then cracking the air about a third. Just get enough there to float it, and then keep running, and then add more air as needed until you get near the end of the path, and then you're probably wide open. But open it slowly, use the air as needed. Two things I've been working on the last year with the Nano and the Micro Flow. I apologize for my typo in micro there. Down in Duncan, South Carolina, is a good partner of ours. We're working with them on their EABF, or their enterprise air-blown fiber. A lot of guys using that in some of these electrical utility companies. For our Nano or Micro, we're working on getting the approval from them, which you should have early next month. We did sell 9 units to Excel Energy out of Minnesota to use this fiber, and so far they're loving it versus the the Ultimates they're using through Plimitas. Verizon Wireline, which uses a Corning Flex up in the northeastern part of the United States. We got approval from them with the Nano machine, as well as Clearfield for the field chilled. It'll work with that. It'll work with also all the Prismian cables that SOS represents. We haven't had much experience or much exposure to those yet, but it will work. Our machine is agnostic to the type of fiber. It really we don't mind whose fiber it is. It'll fit the machine. It'll go. The Mini Flow Rapid, as I said in here, we've got the approval somewhat through Bell Canada. Hoping to get that fully in writing from them. And really, the multi-flow and the power flow, really any OSB fiber will work. Here's some information on our competitors. When you hear things out there, the first one we talk about is Plimitas at the top. You may hear Plimitas referred to as Sherman O'Reilly or Greenlee. That was up until December 31st of last year. Plimitas is a company out of Sweden that actually manufactures that unit. They no longer are utilizing Sherman O'Reilly or Greenlee to distribute in the U.S. I believe it's the same way in Canada as well. That they are now Plimitas direct and are going to market. They only sell direct. They do not sell the distribution. They will only sell direct to the end user or the contractor. Pros that they've got is name recognition. Everybody knows them by those names. Perceived quality, people think that they're the Cadillac. We have some. we can say that they don't. Some of the cons are they are a very high cost machine. Our machine is going to come in well less than theirs on price. Now that they're no longer part of Sherman O'Reilly and Greenlee, we're still working on vetting out where the pricing is going to be. I've heard it's come down considerably, but I'm not seeing a formalized quote. I still think we're still underneath them on price point. One of their cons to them, long lead time and availability of their product line. With them now not having the Greenlee and Sherman O'Reilly part of it, they're going to, again, be difficult for them to supply as they build up with their inventory levels here in North America. Conducts, American-made out of Mankato, Minnesota. The thing about Conducts is once people use Conducts, it's kind of that's Chevy, Ford, Chrysler. That's what they like. That's what they're going to use. We have proven they are still a higher cost. They're not as dependable as ours, and the lead time of their products are very, very difficult to get. Again, not to mention they don't perform well in inclement weather. They don't run well in the rain. They don't. There's a lot of different sealage and little pieces, parts you need to run the machines, where ours will outperform them hands down. General Machine products, GMP, the Tornado you hear a lot. It's a machine I've sold a ton of in the past life. It's a great little machine. We are not going to be as low priced as GMP. I can get to it if we're competing against them directly. I can't get down that level. I don't want to. I think our machine has a more powerful insulation force and can reach further lengths. I've been hearing more and more that they don't have anything in stock as well. So when we'll beat them is we have the inventory in South Carolina. I've got the majority of the pieces parts there. We can't supply, same day if not next day. If somebody needs adapter pieces or seals or need a machine, we have them in the field. Big thing is I was talking to Norm and Amanda about earlier is that it's a different sell compared to selling hard parts. It's just capital equipment, and some people are somewhat scared off by it or don't want to bring it up. So you don't know how to really sell it and bring it home. That's where I come in. What I really need for you guys is to ask the questions of your contractors and your end users. I mean, ask them if they're installing fiber. If they are, how are they doing it? Using traditional versus micro. They looked at jetting at all. If they are, who's they using? These are preliminary questions. And then the big thing is, if you get something with a pulse or something that has any kind of legs to it, engage me early and often. Let me vet out those questions with them. Determine the best machine for them, and it can work for the application. Biggest thing is we need to know the duct size and the fiber size. That's going to tell us the majority of what I need to really get in there and get involved. I will tell you, the more and more we get into demos, getting spec sheets for exactly the fiber they have
is crucial, because we go out there and we're told it's a Prismian 1728. I did a demo yesterday in South Carolina. We were told at first it was a Prismian 1728, but it was a different style of fibers, or Max, I can't remember the name of it, Max something. The traditional one was an inch and a quarter in diameter, and this one was just less than an inch. So getting the proper pieces, parts to it, it's critical to go out there and know what we're dealing with in the field. Some things we've added. This is a nice picture of what the multi-flow looks like on the left-hand side. The mini flow is here on the floor. We sell it with these cases or without. It is optional. These nice metal jobber cases that we can use that have a stand on them to put the machines on. These are some new things that we at Jameson have done these machines since last year. This is a picture of our aftercooler. This is agnostic to the machine, so if somebody has an alternate machine and they are working in a warm air environment and want to cool it down, this will work with on a GMP Conducts Plumtas machine, agnostic machine. We make them in Clover, and also are cost competitive to most of the other dry air or the Sherman Rileys out there today. Y blocks, another universal item. A Y block is used if you have an existing conduit with a fiber in it and you need to put a secondary fiber in. You can utilize this to capture the air away from the machine and actually install a secondary cable. This, again, agnostic to the machine. This will work with anybody's machine out there, and this is universal. At each end, you can put in your whichever size duct collet you need. If you're using inch and a quarter or 2 inch, this will adapt to both, or basically 3/4 inch through 2 inch. It will adapt to. Another little item we have here, this mini junction blowing block. I think there's some great potential for this one. This basically uses air only to install the fiber. And so some of your harder strength number fibers, you can use this to actually hand push in. I'm working with them on a version of this for flat drop. If you see the little seal here in the beginning, if we make that as a oval for the round drop with 2 strength numbers and a flat drop for doing quick drops to the home, hook up air to this, open the valve up, you're going to add the air, and then just kind of hand push in and get those distance of a couple hundred feet. Should be no problem to do without having to have a large machine out there. And at a cost of less than $1,000, this could be a big winner for us.